They all will face the same challenges the car manufacturers in general have. So it's all about safety, reliability. So anything which could harm human life, of course, must not happen. And therefore, we expect that reliability, delivering highest quality is a key issue in this market. And this will also more or less clean up probably the landscape a little bit in case some, let's say, hiccups will take place. Challenges will be, of course, that in the whole transition from the combustion engine to EV, the complete supply chain will be transformed. So the typical tier 2, tier 3 suppliers in the today's car world, this picture, this landscape will change with moving to EVs. Another very important aspect will be how the charging infrastructure will cope with it. So you probably know that a couple of car makers work on their own charging structure, but on the long term, we need to provide the charging infrastructure like it is given today for combustion engines. As long as this is not available, there will be, let's say, more mental hurdles in place. So this will be a very important aspect, how the charging infrastructure can keep the pace with the introduction of the electric vehicle. And cost, of course, is the final very important point. So if you take now, if you compare especially for the traditional car makers, the combustion engine and the same type of car coming along with an electric or hybrid propulsion system. So the cost difference is still significant. So this needs to be addressed. We expect that the market for electric vehicles will continue to grow. I think a plateau is not yet seen. We expect here a growth rate of 17% CAGR over the next up to 10 years. So it's really booming a lot. So there is the driving force to reduce the CO2 footprint. Diesel topics have been heavily affected, the whole story. So EV market, including the charging infrastructure, which is required to push the market, this is where we believe a significant portion of the growth in power electronics come from. Silicon, of course, let's start with the most easiest one. That's the most mature technology, highly productive, highly cost efficient in manufacturing. And for most of the applications in the semiconductor world, still sufficient. But it always depends on the needs in particular applications. If you look on IoT solutions, so integrated circuits here, we often see silicon germanium as a combination, which is very effective in modern digital circuitries. I think the dominant material still will be silicon in most of the areas, maybe except optoelectronics, which is governed by other compound materials, and also the high-end radio frequency components, which we have to use, for instance, for 5G. So this also will be no longer silicon, but gallium nitride grown on silicon carbide. If we come back a little bit to power electronics, so in power electronics, we also believe that silicon is able to serve most of the applications in the future in a sufficient way, especially since also here we still see room for improvement in areas like superjunction devices, like low voltage silicon MOSFETs, and even IGBTs. Silicon carbide steps in, from our point of view, in the arena where driving forces are especially power density and efficiency in combination. So where we have to go for disruptive solutions with respect to size and weight. We also expect that more or less each and every segment where today IGBTs are used, step-by-step silicon carbide will take over a certain portion. It will not eliminate silicon, definitely not. But up to a double-digit percentage of the today's IGBT market, we expect in the next 5 to 8 years will be covered by SiC. Gallium nitride, with its special advantages in the very high frequency area for power supplies and the ability to integrate, of course, opens up other horizons regarding system solutions or system on chip solutions, but from our point of view, more restricted to, let's say, medium power rating. So single to double-digit kilowatt ratings in the area, maybe of 600 to 800 volt blocking voltage. So this will probably be the playground gallium nitride technology. Of course, then also down to lower voltages, 100, 200, 300 volt. So all materials have their advantages, but none of them, I would say, is a certain winner or loser. So we will have more applications coming up, therefore more room for alternative semiconductor solutions, and we expect here a healthy neighborhood between all the materials we have talked about so far. I had the pleasure to be more than 20 years in this business, so I'm always excited again about new applications which prove that the future for power semiconductors is really bright. So to give you one example is if we just take the area of renewable energy, which 15 years ago was more or less not present. Today, a large portion of the power electronics goes into solar and into wind, and a new development over the last years was, for instance, that meanwhile to each and every solar power generation plant, storage is added. So each storage system again needs power semiconductors. So there will always be, let's say, new needs in the area of power semiconductors, and this is really driving here the development forward. And it's just the question: can we keep the pace here? So are we able to follow this very dynamic development? And for that, of course, we need to be in a let's say, healthy business situation to have enough backbone and background to finance future developments.